Greetings to all of you. The session is regarding intermediate chemistry. This content is helpful towards international entrance and competitive exams as well. In addition, India level, JEE Advanced, JEE Mains, this is for IIT, NIT entrance examination across India. NEET chemistry will be helpful for medical entrance examination. And Telangana Andhra Pradesh government conducting MSET examination will be fetching for your engineering entrance, that is BTech entrance examination. In addition, if you're aspiring for any government organized career opportunities, there general studies will be the common question paper. The general science content will be there. The content what we are discussing is very much helpful in that preparation. Let's discuss about question number 1. Explain the isomerism of following compounds. Two compounds are provided named as D-glucose, D-aldrose, where C2 and C3 carbons only find a difference in the arrangement and else is exactly same in both the compounds. Whenever these compounds are mentioned, the isomerism is regarded as diastereomerism and both are called diastereomers. Let's see what is meant by diastereomerism. Diastereomers defined as compounds which have same molecular formula and sequence of bonded elements but non-superimposable, non-mirror images. Non-superimposable in the sense, if you take both the molecules, if you put one upon another, both are not exactly resembling. And moreover, if you put a mirror in between, both are not exactly resembling one with other. That is called what? Non-superimposable, non-mirror images. This is the way question number 1, option number 2 is the correct answer. Move on to question number 2. Question number 2 is collected from Cambridge Assessment International Education. The plunger of the gas syringes is pushed in. The temperature does not change. The mixture initially turns dark brown. After few seconds, the mixture turns to light brown because the equilibrium shifts to left side. Whenever the reaction carried between N2O4 gives rise to 2NO2. This is called what? Decomposition followed by dimerization. So N2O4 is the colorless gas. NO2 is the brown color gas. Okay. There are two questions posed over here. Explain why the mixture initially turns darker brown. Initially turns to darker brown. Why? Because N2O4 got converted into 2NO2. Let me show. I am NO2, it is saying. NO2 is a dark brown color gas. The question got answered. Explain why the position of equilibrium shifts to the left hand side. Okay. So, turns darker brown. Mixture initially turns to darker brown. That is because of the formation of NO2. So, whenever equilibrium is achieved, the equilibrium will shift towards the left hand side. Why it is shifting left hand side? This is explained based on Le Chatelier principle. What Le Chatelier principle says? Le Chatelier principle is by decreasing the volume, equilibrium is shifted towards left hand side. Less number of moles. So if you observe N2O4 and 2NO2, here starting material is having 1 mole and the product is having 2 moles. Whenever we are applying we are considering the equilibrium always shift towards less number of moles. Less number of moles are there in the reactant side. That's the reason why left hand side reaction is shifting and the colorless gas is generated within the vessel, so that initially dark brown, now it is becoming a light brown color. That is because some existence of N2O4. This is the way equilibrium is shifting left hand side in accordance with the Le Chatelier principle. The direction is showing towards the reactant side, less gases side, less number of mole side, right? So this is the way question number 2 is answered. Move on to question number 3. Question number 3 is collected from JEE Advanced 2018 question paper, paper 1 question. It is consider ionic solid MX with the sodium chloride structure. Construct a new structure Z whose unit cell is constructed from unit cell of MX. following the sequential instructions given below. Neglect the charge balance. Okay, there are certain instructions are provided. According to these instructions, from the existing solid, you have to construct a new unit cell of compound MX, right? So in the step 1, remove all the anions except the central one. Central anion remains, remaining all the anions got removed. Replace all face-centered cations by anions. All face-centered FCC cations are removed. Instead, anions are inserted. Remove all the corner cations. Corner cations now removed. Replace central anion with the cation now. So, anion now replaced with the cation. The value of number of anions by number of cations. Number of anions, number of cations ratio is calculated as Z. What is that Z ratio to be identified? That is calculated as 3. How can we answer this 3? Let's see. Here, step by step we have, as per the given information, cation form FCC lattice. Face-centered cubic lattice is formed by cations. Anion occupy all octahedral voids. Wherever octahedral gaps or voids are present, at that position, anions are occupied. Right? In the step 1, 4 ions of M plus and 1 ion of X minus will be there. In the step number 2, 1 ion of M plus is there and 4 X minus ions will be there. Step number 3, 0 ions of M plus are there. 4 ions of X minus are there. Step 4, 1 ion of M plus and 3 ions of X minus are there. Right? Finally, 1 cation, 3 anions are located. The ratio anion by cation, where finally we have 3 anions by 1 cation. 3 by 1 is nothing but 3 only. Right? So 3 is the correct answer. According to the data, we made all the assumptions. So that question number 3 correct answer is 3 only. Move on to question number 4. It is collected from JEE Advanced 2018 question paper, paper 1. It is again 2018 only. For the electrochemical cell, the question given from electrochemistry and it is the part of physical chemistry. For the electrochemical cell, magnesium, magnesium plus 2, copper plus 2, copper solid can be taken. And aquated solutions are 1 molar in nature. This is called what? Cell notation. The standard EMF of the cell is 2.70 volts. Standard EMF value, E0 value is given as 2.70 volts at 300 Kelvin temperature. When concentration of magnesium plus 2 is changed to X molar, the cell potential changed to 2.67 volts at 300 Kelvin. The value of X is what concentration we are changing, that to be identified. Here, Faraday by gaseous constant is equal to 11,500 kilovolts, where Faraday is Faraday constant, R is the gas constant. Log 10 value is given as 2.30. The expected value is 10. How can we get this 10? Let's see. To calculate this one, we have the half cell reactions. Magnesium having tendency to release the electrons and follows oxidation process. Magnesium gives rise to 2 electrons and forms magnesium dication. Copper plus 2 having natural tendency to gain the electrons so that metallic copper will be formed. It participates in reduction. The complete redox reaction is magnesium metal, copper plus 2 ions gives magnesium plus 2 and metallic copper. This is the complete cell reaction. Here, applying the Nernst equation. What is Nernst equation? E is equal to E0 minus RT by NF, ln product concentration by reactant concentration. Here, standard value is given as 2.67, 2.7, E cell value is given as 2.67, standard electrode potential value is 2.7, R is the gas constant, T is the temperature, N is the valency, F is the Faraday. Here we have Faraday by gas constant value. So that let me invert that. Ln X by 1. X to be calculated, right? So here Whenever you are taking this difference, it will become 0.03. Then temperature is given as 300. F by R value is 11,500. R by F will be 1 by 11,500. And N value is 2 because 2 electrons got released and accepted. Valency is 2. Ln X to be calculated. Right? So if you do entire thing, ln x value is 2.3. Within the problem they mentioned log 10 is 2.3. So that x value will be 10. X is equal to 10. So this is the way problem can be solved. For question number 4, correct answer is 10. Move on to question number 5. Question number 5 collected from Telangana MSET 2023 entrance examination. In which of the following the order of elements against property mentioned is not correctly matched? Here, this is the periodicity based question and especially inorganic chemistry question, periodic properties. క్రింది వాటిలో దేని యందు మూలకాల క్రమం దాని ఎదురుగా సూచించిన ధర్మంతో సరిగ్గా జత చేయబడలేదు. ఓకే, హియర్ ionization enthalpy, melting point values, covalent radius, boiling point values. Ionization enthalpy, ద్రవీభవన ఉష్ణోగ్రత, కోవలెంట్ వ్యాసార్థం, బాష్పీభవన ఉష్ణోగ్రత. All these are the properties. For carbon, silicon, germanium, lead, tin. All these elements belongs to 14th main group. Okay. Among all, which is not correctly mentioned is, so this is melting point value. Let's see how can we explain. First property called ionization enthalpy. In general, what is the periodicity? Ionization enthalpy values decreases as one moves from carbon to silicon. So that carbon, silicon, germanium, lead and tin. Lead and tin will be the order due to the ineffective shielding of the d orbitals, f orbitals. Lead has the higher ionization enthalpy than tin. So lead has the higher ionization enthalpy than tin. This is the exceptional where it is mentioned correct only, right? And melting point. Move on to melting point values. If you observe the melting points of all these, 3730 for carbon, 1410 for silicon, 937 for germanium, 232 for tin, 327 for lead. If you see, lead is higher compared to tin, but they mentioned as tin is higher than lead. This is the wrong direction, so that you can cancel out option 2. Covalent radius. Covalent radius is mentioned. Covalent radius is mentioned here. Carbon 0.77, silicon 111, germanium 122, tin 141, lead 144. If you observe what happens, covalent radius gradually increases because number of shells increases in a group. In general, always atomic radius, that might be covalent, van der Waals, whatever it kind be, gradually increases in a group. So that we can say whatever they mentioned, lead is higher, tin, germanium, silicon and carbon is the smallest. This is the correct order. Boiling point values. If you observe the boiling point values, here, silicon is having 3,550, germanium 3,123, tin is having 2,896, 2024 for lead. Gradually decreasing, no ambiguity. Entire values are decreasing. So that silicon, germanium, tin, lead is mentioned. Carbon, whose boiling point need not to be calculated, which is not mentioned. So that only the wrong answer is option number 2. For question number 5, option number 2 will be the correct answer. Move on to question number 6. Question number 6 is collected from IUPAC nomenclature. IUPAC stands for International Union for Pure and Applied Chemistry. According to IUPAC, compounds are given with systematic nomenclature. This is the compound given where carbon, carbon, carbon with a 3-methyl in the terminal carbon atoms. For this compound, the correct answer is 2, 2, 4, 4 tetramethyl pentane. Let's see how can we get this name for the given compound. In order to explain that, let me expand this chemical structure. Here, here CH3 taken thrice means what? CH3 is there 3 times. So that let me mention entire carbon chain length like this. 1, 2, 3, 4, 5 carbon chain length will be there. And on the second carbon, you can put methyl and methyl, because here we can find 3 methyl. No, one of the methyl is the parent chain only. 2 methyl will become a substituents. And the fourth carbon, even on the fourth carbon, you can find 2 methyl and one more terminal methyl will be there. If you count the number of carbons, 5 carbons you can notice. 5 carbon is designated as a pentane. Parent chain will be pentane. And you can find methyl on second carbon, methyl on fourth carbon as well. How many? 2 methyl on second, 2 methyl on fourth. So that let me put the entire name. 2 comma 2 comma 4 comma 4 tetra methyl pentane. This will be the systematic nomenclature. Indeed, we can say IUPAC nomenclature for the given compound, right? 2 comma 2 comma 4 comma 4 tetra methyl pentane. So for question number 6, option number 4 is the correct answer. This is the way we can go through the various dimensions of chemistry and various fields of chemistry got considered. Problematic session, analytical part, IUPAC nomenclature, inorganic, physical chemistry, organic chemistry, everything got covered over, so that this is the session really informative towards your preparation. Hence, I'm sincerely requesting to like the channel, comment, share with the aspirants, subscribe. Thank you very much for your patient listening.